So, hello everyone. In last class we have discussed the first system of measurement of fabric handle characteristics. So, we have mentioned that two commercially available fabric handle characteristics measurement systems are there. One is KESF, another is FAST. Today we will discuss another method of measurement, which is fabric handle by or fabric feel by extraction principle. So, it is not very new, it is actually it is a very common practice to know the fabric softness or fabric handle for many years using the extraction principle. Okay. So, it is actually it is a useful technique to judge the fabric handle. It is a quantitative value we get, very old techniques among the ladies. So, where the fabrics are being pulled, particularly scarf or any soft type of fabrics are being pulled muslin through the ring, and judging the overall load required to pull the fabric. Okay. So, this similar technique, similar principle is being used here to know the fabric handle or fabric feel related characteristics. So, this system, this principle is not new. So, here the circular fabric of 25 centimeter diameter is actually held by a pin at the center and is drawn through a cylindrical nozzle, okay, highly polished nozzle made of maybe steel, maybe any other material, maybe plastic. The force required to extract the fabric through the nozzle is measured. Okay. And the sample here, while pulling through the nozzle, the sample is deformed, there is a complex deformation, okay, at low stress level, okay, where is that may be a tensile deformation, maybe shearing deformation, maybe bending deformation. There are action of friction between the nozzle surface and the fabric. So, all complex deformation takes place during the pulling, and which are actually related with the fabric handle characteristics, and all these different types of deformation gives one unique value of the pulling force, and from this pulling force we can get idea about the feel of the fabric. So, the principle here is that it is there is a nozzle, it is a nozzle is there, it is a hole is there, and this is the grip. At this point it is a grip at the center if it is a circular fabric, and the fabric is pulled through this nozzle, okay, and the load cell detects the amount of load, okay, amount of load during the pulling. And as I have mentioned, this system, this principle is of measurement, it exists for a long time, but this nozzle extraction principle is also not new. Okay. It is actually proposed in say in 1930s by Pierce, who has proposed this principle first, then Kawabata proposed in 1980s, then Postel, who has proposed this principle in 1989, that the following characteristics of fabric deformation have to be captured by measuring the the force. Okay. This measurement at by low yet complex stress at large deformation. So, at large when we keep on pulling the fabric at large deformation, this low and complex stress we can measure, which is non-linear in nature, and the friction and hysteresis we can measure. So, the present approach which we have adopted here, it's our idea is to measure a fabric handle or fabric fill with a simple and quick measure objective assessment, and it should be user friendly. There should be a single value of fabric fill value that we have developed. We have got a fabric fill factor that we will discuss here, and this fill factor we have measured compared with the subjective assessment. So, single value, getting a single value was our objective, and one real time graph we can get while pulling. We will get a real time graph of pulling force and displacement. We can test wide range of fabric from very stiff fabric to very flexible fabric we can measure in the same instrument, and moreover this instrument should be as simple as that an unskilled shop floor worker can handle, because this is using this fabric one can compare the softness characteristics of fabric, and the instrument should be cheap enough, and so that small scale industries they can afford. Other instruments, commercially available instruments we have seen, these instruments are very expensive. So, we cannot, the industries normally they cannot afford. And next, another problem is that those instruments are so complex, the actually measurement is very complex. So, the repeatability is very difficult and analysis is difficult. So, this approach was that it is a simple instrument, a unique data we should get, and it will we should get a unique value, so that it gives the fabric handle. So, the approach we can, if we see here with the animation, if we see, this is the nozzle, it is a ring type nozzle. Here it is a fabric holder, this one is fabric holder which is connected with the load cell, okay, and there is a clamp which is holding the load cell, and there is a traverse arrangement. This is a holder, it is a crosshead which moves up and down, and the fabric after cutting it is placed through the nozzle and gripped by the fabric holder, and as the nozzle has got it is a special type nozzle which has got 2 extra load cells. Okay. In case of when we extract fabric, we will have a longitudinal load which is sensed by the load cell 1, and also during extraction it exerts radial force. That radial force that is measured by 2 load cells, load cell 2 and load cell 3, 2 radial direction force, and we get total picture of the load value during the extraction. Now, let us see, this is the fabric sample which is first inserted through the ring, and it is gripped by the fabric holder. This is the placing of the fabric. Now, when we start the nozzle extraction, the x axis is the its time, and here this is the radial force and this is the extraction longitudinal force. So, this is the load cell 3, 2 and extraction is taking place. So, we get 3 different graphs. This is from the load cell 1, the extraction at peak, this is the radial direction 1 and radial direction 2 and mean of this 2 we can get. So, this is the basic principle of this instrument. So, this is the nozzle, if you can see the picture, this is the nozzle and this is the fabric holder here, this is the fabric sample. So, here as we mentioned it is a compression, bending, biaxial extension, friction, all complex deformation take place and ultimately we get one parameter. Okay. Complex stress, non-linearity is there. So, this is the prototype of the instrument. So, if we see the video of this testing in the laboratory. So, here if we see that it is a this is the instrument. Here this is a nozzle one, okay, fabric holder and the panel. This is a nozzle. Computer monitor is there. Now, the fabric is being pulled, okay, through the nozzle. And here we are getting graphs. So, extraction force and this the graph. So, and now as soon as it is out, so the test is completed. Okay. So, we get the complete curve. So, we can we have tested. So, different fabrics we can test. This is another fabric. So, different types of extraction force and displacement curve we get, and this the x axis is its displacement. Okay. So, this commercial instrument is also available here, and these are the different parts as we have explained earlier also. So, the basic purpose of this instrument is to measure the fabric fill objectively. So, we can sense the fabric fill subjectively as we know. So, it is an objective measurement of fabric fill. So, it eliminates all the subjectivity, giving one unique data to select the optimum fabric by comparing the fill. Okay. So, if we want to select a fabric, it cannot because that value, the fabric fill value or extraction force value, we cannot actually use this value as a benchmark. Only thing here we can use this value as a, to compare with other value. So, for example, we have given 10 finish application, 10 different types of finish for on a particular fabric. Okay. We want to know which finish is the best as far as fabric feel is concerned, fabric softness is concerned. That comparative value we can get, but if we want to know the what is the value, that value is immaterial here. What is the finish the softness value, that particular value is actually immaterial here. Here we can give we can get comparative value. If we have certain number of say 10 different fabric, we can tell okay, out of this 10 fabric which one is softer. Okay. But that getting a particular specific value, it is immaterial, because the extraction force depends on many other factors, like a fabric which is in little bit stiffer in nature, say like a denim fabric, we cannot compare denim trouser fabric with fabric, cotton fabric with for used for say shirt. That cotton fabric used for shirt, the light cotton fabric used for shirt will always give lower extraction force. Denim fabric will always give higher extraction force, but that does not mean denim fabric is feel wise it is very harsh, it is not that. If we have to compare, we have to compare denim fabric with denim fabric. So, that is the, if we can say that is the limitation of this system, but it works within a particular set of fabric material. We cannot compare between different family, within same family we have to compare, we can tell this fabric is best out of this lot. Okay. So, to check the change in fabric feel after chemical or mechanical treatment. So, that this instrument we can tell, okay, after some chemical fabric we have given some chemical treatment. So, this fabric will give idea about the change in fabric feel. That same fabric, but different chemical or mechanical finish if we give, this instrument will give us idea about the change in the feel of that fabric. The feature is that is a quick assessment and it is user friendly. It is a single test for fabric feel value, not like other complex system where a large number of test value we have to get, we have to test the bending, we have to test the friction, compression, extension, then we get a certain value, but here we get a single value, a real time graph it gives, and different nozzle diameter we can use. So, for very stiff fabric we can use a larger nozzle diameter, or very limpy fabric, or say knitted or weft knitted fabric we can use very small nozzle structure. For nonwoven fabric, so wide range of fabric we can use by changing the nozzle diameter, different nozzle material we can use, different operating speed we can change depending on the type of application, and the instrument is cheap instrument. Its idea was so the potential users of this instrument is dyeing and finishing industries. If the finishing and finishing industries they want to develop some some particular finish for better tactile sensation, they can use this instrument. Okay. After dyeing or after finishing, what is the change in fabric feel or fabric handle characteristics, we can this instrument can give idea. The weaving industries they can set their parameter for different handle characteristics. Garment manufacturing industries they can use to buy their raw material, the fabric. Buying house they can use, testing laboratories and academic and research institutes they can use for their research. Okay. And it is a possibility of evaluation of different other products. So, not only fabric textile material, for different other industries one can use this say paper industries or some other industries, this instrument can be used. Now, the typical graph, as we have seen in the video, this is the typical graph out of the instrument. Okay. Displacement x axis shows the time and we can convert it to displacement, and y axis is the force, this is the extraction force, these are the radial force, and these are the parameters we can use to develop fabric feel. Okay. The area under the extraction curve, okay. The unloaded fabric across the orifice, that is nozzle for extraction A, that is length of the. So, we can discuss here. So, this is the length, that is the up to this length A distance there is no load, that is the A distance, and this is the area under the A curve, that is area under the this extraction. Okay. Similarly, the peak distance for extraction curve, so dE. So, this is the dE extraction curve, this is the peak distance. Okay. So, radial peak distance, peak height of extraction P e. So, area under the radial curve, okay, radial force curve, peak distance for radial curve and peak height for radial. So, these are the parameters. All these parameters are being used to measure the fabric fill factor. So, using the statistical technique, we have developed one equation which is actually which gives the fabric fill tester. We will discuss. Okay. So, fabric fill value which is, so the research study we have carried out. So, the material which we have used commercial denim fabric from one industry we have used. For measuring the fabric fill, effect of functional softener we have used and different denim finish treatment. A particular fabric was selected, the fabric constructional parameters, these are the fabric constructional parameters. Okay. This is open end, ends per inch, peaks per inch, fabric width, and these are the, this is the twill fabric. So, these are the different specification. Functional softener has been used, silicon softener, time, pH level and dosage 20 gram per liter, 40, 60 and 80 gram per liter. This different dosage has been applied. Now, these fabrics have been subjectively studied, actually assessed. So, subjective assessment, it is basically at a 5 scale point has been, rating scale has been provided. So, 1 means it is very soft, 2 it is better than it is a softer, okay, soft, and 5 is least soft, it is a harsh fabric. There are actually the evaluators are of 2 groups. So, textile person who knows about textile, who has some knowledge about textile, the 10 evaluators have been taken, and those who does not have any textile knowledge. Okay. So, they have been 10. So, total 21 evaluators have been used actually. So, they have been asked to rank the material. So, this actually the fabric ranks increases with the, this is the ranking. So, the raw fabric gives the lowest rank. So, as we go on increasing the softener content, softener concentration, the ranking increases, that the 80 gram per liter it gives the highest rank, that by softness wise it gives the subjective assessment, it is basically it is a harsh fabric, it is a maximum, and this is the very soft fabric. So, it is actually for a different group, it gives the uniform rating we got. Okay. And now, the objective rating we have got. So, objective rating, it is a raw, means without any finish, without any finish. So, radial average radial value, radial force we have got, and average that extraction force, longitudinal force. So, this we have got, this is little bit higher value, and that this is the peak force by the instrument. So, for 220 GPL, 40, 60 and 80. So, what we have observed, so with the increase in concentration of softener, subjectively it has given the softer feeling which we have got, and this is also indicated by the extraction force. So, extraction force is the indicator of the subjective feeling. Okay. So, but what the basic observation was that although this is giving indication, but can we get some better indicator which will give us a clear idea about the subjective rating of fabric fill. So, then we started working on that on the graph, okay. And here we have taken 10 different finishing, and we have taken again denim. Earlier study what we have used, we have changed the concentration of a particular finish, okay. But here we have taken 10 different types of finishes, which is actually common for denim: raw fabric, raw washed and decised, which is only decised, which is marked as sample number 1. Sample number 2 is enzyme washed for 60 minutes. Sample number 3 is enzyme washed and heavy bleach then washed, and enzyme bleach and tint wash, enzyme tint wash, enzyme ice washed, enzyme ball washed, stone wash for 75 minutes, enzyme and slide beach wash. So, these are the different type of wash fabric, and what we have got, these fabrics we have again actually tested subjectively by large number of evaluator. Here we have taken a large number of evaluators. The evaluators are of different group, 8 different groups of evaluator, and total we have more than 100 evaluators, 123 evaluators assessors. So, this total 123 assessors, they have been trained for the softness value, and here our idea was to evaluate the fabric in 10 different scales. 10 different scales what we have got, the softest, high, moderate, low. So, if you feel the fabric is very soft, then also you rate the fabrics in high, moderate, low. Similarly, it is medium soft, it is high, moderate, low, soft, high, moderate, low, and hard. If it is very hard, you cannot place anywhere, that you can. So, the evaluators, they have not been actually disclosed the type of fabric, okay. They have been only asked, you give us the overall softness value, and this is the rating scales have been developed, okay, and the evaluators are of different background, of different age group, okay. So, and total 123 evaluators have been taken here. So, scale 1, which we know it is a softest fabric, and scale 10 it is a harshest fabric is there, okay. And what we have got here, it is a this fabric, it is a almost 10, which is harshest fabric, which is basically ultimately which is not being washed fabric, and fabric softest fabric is this one, okay. And we have also measured the correlation between the different among the different evaluators, and this evaluation, the softness evaluation, fabric feel evaluation is it is a subjective evaluation. Is the same fabrics we have tested by the instrument, and we have got different curves, and from there, as we have mentioned that PE, WE, this PR, DR, these are the parameters which we have got from the extraction curve, nozzle extraction curve, that is and radial force and energy and work done. So, all from this curve through the statistical analysis, we have got this is the equation which gives the fabric feel factor, and this is this values we have got by the curve fitting, and this fabric feel factor, the values have been selected in such a fashion that it is actually scaled in such a fashion that feel factors range is between 1 to 10. So, that we can in our subjective assessment, we have got the value of subjective assessment from 1 to 10. The feel factor also has been actually converted in terms of 1 to 10, So, 10 means hardest value and 1 means it is a softest value, and we have seen this the correlation between subjective assessment and fabric fill factor. This is the fabric, it is a very good correlation we have observed. Okay. And this subjective and assessment of fabric fill, and so from here we can claim that this instrument gives very good subjective assessment, so very good actually indication of the actual fabric fill in use. Okay. And where we have got the correlation coefficient is close to 1, basically it is a perfect 0.977 is the correlation coefficient we have got. But this fabric fill factor, it is a we have to analyze, we have to get the from the total curves. So, the software is there. So, just after testing a particular, and if we feed this fabric fill factor this value equation, the automatically the software will give us the fabric fill factor. This equation is developed for the denim fabric of that particular range. Now, then we thought that okay, let us try to correlate with the subjective assessment value with the peak extraction force, but which we have got, it is a correlation coefficient is we have received, it is a much lower, although it gives certain indication, but it does not actually give the it correlate well with the subjective. So, our recommendation is that it is ultimately we have to analyze the total curve, then we can get the total fabric fill factor, and this fill factor is correlated with the subjective assessment. Then what we have tried? We have tried the average radial force and average extraction force, that we have tried to correlate. So, this correlation is close to 0.99. So, the idea is here. So, whether do we need the radial force measurement. So, although it gives the idea about the extraction force, average extraction force gives a clear idea about the radial force also. So, we can make the instrument much simpler to have only extraction force, and also the equation much simpler to give the get the value of the subjective assessment. Then we have tried to correlate this extraction force with the different parameters we have which we can receive from the KESF instruments. So, finally, what we have observed, we have concluded this basically there is no such proper correlation between the extraction force or this each of the other parameters, individual parameters. So, that we can conclude that the extraction through extraction value, the whatever extraction force we are getting, it is a complex combination of all this. It is not the with the individual value, we cannot compare with any of the individual values, but it gives a complex combination of different parameters, and ultimately it gives a unique value, which we have actually seen it is very well correlated with the subjective assessment of the fabrics. Okay. So, now we will discuss the various this parameters, how these parameters are actually reflecting the actual fabric. We will give some, now we will take some example of actual fabrics, the fabric feel, fabric tactile sensation, and how these parameters are related. So, fabric parameters affecting the tactile sensations are bending, shear, fabric roughness, scratchiness, fabric prickle sensations, fabric clinginess, and fabric warm and warmness and heaviness. So, all these sensations now we will discuss, and how the fabric fiber and fiber yarn and fabric parameters affect all these sensations, bending related sensation, shear related sensation, fabric roughness related sensation, all these sensations are related with the fiber characteristics, yarn characteristics and fabric characteristics. These things we will discuss now. Okay. So, bending and shear, all this we can directly relate it with the KESF value, fabric hand value, okay, and type of fabric finishes. So, these things we will discuss one by one, and the fabric parameters actually which affect the which is affected by the type of yarn used, type of structure, type of number of ends per inch, peaks per inch, okay, and ultimately it gives the tactile sensation. Now, here now we will discuss the one study which actually shows the effect of weave density, the ends per inch and peaks per inch, the amount of twist, the change in twist, and yarn count, how all these parameters affect the fabric tactile sensation. Like as we have mentioned here, these are the tactile sensations, roughness and all this, prickliness. So, here in this study polyester fabrics have been taken, polyester woven fabric. So, polyester it is not the staple fiber, it is a polyester filament woven fabric of different weave density, different twist structure, different yarn count has been taken, okay, and it is tested by objective evaluation using first it is using it is a Kawabata system, and then we will discuss various studies. So, one of the very commonly used fabric for a dress material, it is a taffeta. What is taffeta? It is a most basic fabric which consists of twistless continuous filament in both warp and wave direction, where weft yarn density was changed. So, this is the fabric made of. So, this is the taffeta fabric, the fabric with the picture which is from the look we can make it is a shiny, because of the it is a twistless filament made of polyester filament, both warp and wave direction. Okay. So, effect of twist is not here, it is a twistless. So, weave density is changed because it is a weft yarn density is changed. So, weft yarn number of peaks per inch has been changed here. Okay. So, taffeta is a crisp, smooth, plain woven fabric made of silk. Normally, it is made of silk or synthetic fiber. Here, this fabric is made of synthetic fiber. Okay. So, this fabric is actually characterized in terms of it is a crispy fabric. It is a smooth, but crispy fabric. Why is it crispy? It is a made of filament, twistless filament. Crispiness means it gives some stick slip nature. Smooth fabric, it is a twistless smooth plain woven fabric. So, this is the type of it is a nature of this fabric, okay. And here the variability is that we have changed the it has the wave density, it is from open structure to compact structure. So, it is a taffeta. Next fabric is that again it is a crepe de chine. Crepe de chine, it consists of weft yarn of continuous filament with high twist. So, earlier we have seen both the yarns were twistless. Here warp yarn is a low twisted yarn, it may be twistless or continuous filament or very low twisted yarn. So, we can use normally twistless yarn, warp, and weft yarn a continuous filament with very high twisted. So, due to this high twist it creates little bit creep. So, creep design. So, it has small creep on the surface. So, this small creep on the surface due to high twist in the weft, it gives certain feeling. So, we can just imagine the fabric earlier when there is no twist and the fabric with weft yarn of different twist, high twist will give different feeling, different tactile sensation. The weft yarn density and weft yarn twist are changed. Here the density of weft yarn, that is the weft number of weft yarn per unit length is changed. Okay. So, per weft yarn density and twist in weft yarn is also changed. So, this is the variable here. So, weft yarn density and weft yarn twist is changed here. Okay. Next category of fabric is used here. It is a georgette. It is a very commonly used fabric where it consists of high twisted yarn in both warp and weft, okay, made of continuous filament. So, again due to twist in both high twisted yarn in both warp and weft, the feeling of the fabric, the tactile sensation of the fabric will be different from that of crepe design. So, it has got two types of georgettes have been used. It is a smaller level and higher level of the georgette 1 and georgette 2. So, there are other fabrics. So, we will discuss in the next class. Okay. So, thank you.